We may start with our plenary. All right, it's a pleasure for me to welcome you to plenary number 9. And today being a public day, our intention is to give you a flavor of South African activities in space and go further than that, just to highlight the interactions that South Africa has with other African countries and how those could contribute in advancing South Africa and the continent as a whole in terms of the development of the continent. We'll go beyond that, look at how these activities are linked to other global activities and how we can raise the African flag in international cooperation. And to do this, the number of panelists who I will call to come to the stage: Conrad Wessels from the CSIR, and Benny Feneroff, who is in charge or heading the SKA project, Leanne McKenna, who is the MD for Sansa Space Science, Raoul Hodges, who is the MD for Sansa Space Operations, Herman Stein, who is the head of electronics at Stellenbosch University, and Terry Newby from ARC, or Agricultural Research Council. And to assist me in this, there is Ms. Majaja from the DTI, who will be moderating the session. And we'll have a number of assistants. Could they please stand up? We'll be asking for questions from yourselves. If you have any questions to us from the panel, please put it down. And then we'll try and answer those questions once we've finished with the first session of our plenary. With those few words, I'd like to welcome Ms. Majaja to address the questions to the panel.
Good afternoon, ladies and gentlemen. Welcome again to our panel 9 that Sandile has already introduced. We're happy to see you here today, this being a public day. I'll pose the questions to the panel as follows. What space-related activities does your institution undertake in South Africa? And how are these linked to the broader African continent? And how can they be used to advance the Africa's developmental agenda? That's our question 1. Our question 2 is related to this, goes on as follows. How can these activities that we have asked above foster broader international collaboration and elevate Africa into the global stage? As we are busy with these related activities, what are the challenges and how can these be addressed that we are experiencing as we are implementing the various activities? What are the opportunities, particularly greater African collaboration, and how these can be leveraged? Those are our questions. I think we'll start with Conrad to take to respond to the questions. Conrad?
Yes, thank you very much. Afternoon. I use Earth observation remote sensing to look at natural resource management. And it's from that perspective that I'll be answering the questions. Not necessarily all of them in that order. And I'll highlight the challenges under each of those questions. Firstly, if we look at the role of Earth observation data in Africa's development, Africa has huge environmental challenges. We don't need to highlight them again. I think everybody's aware of that. And the Earth observation data should be used to solve those problems and address what we call societal benefit areas. Now, those societal benefit areas are listed by the group on Earth observation. It ranges from agriculture, ecosystems, natural disasters, climate change, water, energy, etc. There's 9 of them. Now, all these Earth observation applications are developed to address those issues. And that is where Africa can benefit. And it's our duty to make sure that we do. And that these space assets that render the Earth observation data are employed to solve these problems. Next, if we look at South Africa's capacity to do so, firstly, if we look at our institutions, our research councils, the CSIR has invested heavily in the last 5 years to develop core capability, and we've been pretty successful at that. Then otherwise also the Agricultural Research Council and SANSA themselves with their Earth observation unit. But what one needs to stress here is that it's hard to reach critical mass and very hard to retain those people. So it's really about human capacity, human capability development to realize the potential of the Earth observation data. If you look at the challenges we face, a recent report by the IEEE and the NRF highlights that at university level there's really a lack of Earth observation training in our country. It's a historical anomaly, and it's being addressed currently by the NRF and SANSA. They're putting out calls for research chairs in Earth observation, etc., and for postgraduate training programs. But I see that as one of our biggest challenges. So we need to grow the number of people involved in Earth observation and grow their skills. Then really, this should lead to building institutional capacity. So we need to build within universities, within science councils, once again, reaching that critical mass where we can truly build applications and derive societal benefits from the Earth observation data. If we look throughout Africa, it's important to mention the RCMRD in Kenya, Nairobi. They are an intergovernmental body of which South Africa is a member. And they do all types of applications throughout Africa, and we collaborate with them on a number of international projects. Which brings me to the South Africa's role on the international stage. Now, I mentioned previously the group on Earth observation. South Africa is one of the co-chairs and one of the founding members, and we've really played a leading role there. The ultimate goal of GEO is to realize the global Earth observing systems of systems, where all the Earth observation satellites and in situ sensors collect data that are shared and that speak the same language, on top of which you build alert services and all kinds of applications. Now, South Africa has responded to that with a South African Earth observation strategy. And we also participate actively in what they call GEO tasks, which are internationally coordinated tasks on fire, on sensor web enablement, and data democracy. We participate as a country in a number of European Union Framework 7 projects, notably AMSD, which is African Monitoring of the Environment for Sustainable Development. And if I can just mention some detail, there we've implemented in all SADC countries what we call field terminals that receive Earth observation data via communication satellites. So the data is received, processed, then pushed up via communication satellites and received internet independently by each Ministry of Environment in all the SADC countries. And we provide the fire service, the Agricultural Research Council provides the agricultural and drought service. So what I'm saying is we do have capability in South Africa, but we need to grow it. There is capability in Africa, but it needs to be grown. Involving Africans in, for example, the European Union's GMES Africa program, which is global monitoring for environment and security. By involving local experts, you ensure buy-in, you ensure utility, and ultimately that will ensure societal benefit. So it is very important, however, that we acknowledge that we need to invest in the long term in building institutional capacity. I think that's my main message. And then in addition to that, I think at this conference it's especially relevant to say that investments in space assets, such as satellites, are essential. But that has to be balanced by investment in people that's going to use that data to realize the societal benefit. Because that makes those investments work for the man on the street, and it makes it sustainable. Thanks.
Thank you very much, Conrad, for your response. Very good words. We'll now move to our next panelist, Benny Famaroff, to give us his viewpoint on those matters. Thank you.
Thank you, Chair. As people probably know, South Africa, with 8 other African countries, is part of a bid for the largest telescope which will ever be built, the Square Kilometre Array. But we're doing a number of other things. So we've established a radio astronomy reserve in a pristine area, in other words, one where there's very little radio interference. It's in the arid Karoo in our Northern Cape province. It's protected by the most advanced legislation that's been passed anywhere. It's called the Astronomy Geographic Advantage Act, and it empowers the Minister for Science and Technology to either prohibit or modify any activities which would interfere with radio astronomy in that area. We've provided substantial infrastructure on the radio astronomy site in the Karoo, so we've built roads there, we've put in a very big power line, we put in a 10 gigabit per second optical fiber connection, there are buildings and so on. And even before the Square Kilometre Array site bid is determined, we're already in the process of building several telescopes there. So the largest is called the Meerkat telescope. The Square Kilometre Array will consist of about 3,000 satellite dishes. Meerkat will consist of 64 dishes, but even that will make it the largest and most sensitive radio telescope in the Southern Hemisphere, and one of the 2 most sensitive in the world. We've also made a lot of progress in building a telescope called Paper. It's not made of paper, it's actually 64 metal antennas, and by next year it'll be 128. That's a joint project which we're doing with the National Radio Astronomy Observatory in the US and the University of California at Berkeley. And the intention of that telescope is to detect the turning on of the very first stars after the Big Bang about 13 billion years ago. Then we have another telescope called CBAS. That's a joint project with Oxford University and Caltech in the US, and that's intended to survey the cosmic microwave background, which is the radiation left over from the Big Bang. In order to build the Meerkat in particular, and also Paper, We've been building cutting-edge technology in South Africa, and I want to emphasize that we're building it. Although we collaborate internationally, our team is developing the technology themselves. So it's really cutting-edge stuff in composite dishes, very large composite dishes, 12 meters in diameter, digital signal processing, algorithms for signal processing, and a variety of other things that they're doing. In our SK site bid, we're collaborating with 8 other African countries. That's Namibia, Botswana, Mozambique, Mauritius, Madagascar, Kenya, Zambia, and Ghana. And we're proposing that Africa should be the site for the SK. The SK will stretch over 3,000 kilometers. It's an array of dishes and other kinds of antennas. And it will cover a very large area in the Northern Cape, but then we'll have outstations stretching into the other 8 African countries. Our competition is Australia and New Zealand, and the international consortium which will build the SK intends to make a decision on where to build by March or April next year. We submitted our final documentation on the 15th of September last month. This has been a process that we started in 2003. We believe that Africa is an excellent location for world-class science. We're getting really excellent support from governments in the continent. So in South Africa, for instance, we have a special cabinet committee on the square kilometre array, and the heads of state of the African Union unanimously passed a resolution last year giving their full support to the construction of the square kilometre array in Africa, and emphasizing how important it is that science and technology at that level should be available in Africa. Some people have said that Africa has no track record in this area. Well, in the last 6 years, we've built up a really vibrant community of astronomers and engineers working on these projects in South Africa. They work with international collaborators. In our office here in Cape Town, we have just under 100 young scientists and engineers who, in the 6 years that they've been on the project, have really gone to the front of the international technology development for the square kilometre array and proved that the skills and the capacity we have here are really world class. We also have given out 300 grants since 2005 to students, mainly for PhD and MSc study, but we've also created 5 research chairs which have been filled by really top-class international researchers. So we're attracting the best and brightest young people into the program to do science and engineering, not only in South Africa, but from our other African countries. Since 2005, we've already graduated 25 PhDs and 52 MScs in this program. 49 of our grants have gone to students from other African countries, and many of them have now gone back to their home countries, and with the support of their governments are teaching astronomy for the first time. So we now have up to postgraduate study in Mauritius and Madagascar, and we have undergraduate courses in Mozambique, Kenya, Ghana, Botswana, and Zambia. We're working on another project with our African partners, which we call the African Very Long Baseline Interferometry Network. What we want to do there is to convert redundant satellite communication dishes for radio astronomy. And we've started in Ghana, where Vodafone have donated a 32-meter diameter dish to the Ghanaian government. So we're working with the Ghanaian government to convert that. And we're hoping to get dishes in Kenya and other countries, which we can convert. We'll link them all to the Meerkat telescope and to telescopes in Europe and around the world. And various countries in Europe, particularly Italy, are very interested in working with us on that. The Meerkat telescope has made us a lot of friends internationally. We had 500 astronomers applying for time on it. We've allocated time to 10 teams to do very large surveys when it starts working in 2016. But the most important thing is that we're attracting large numbers of young people into the subject, and we believe that we can retain them. So, for instance, 5 of our young people who did MScs here went to Oxford to do PhDs. A couple of them are doing postdocs in the United States, but they all intend to come back to South Africa, and the reason they're coming back is because we'll have an exciting project for them to work on. So, one of the important things for us is that this has raised science and technology's profile in Africa as a development issue, but it's also raised the issue in many other parts of the world, Europe and the United States and other countries, recognizing that Africa can do cutting-edge science and cutting-edge technology as well as anybody anywhere in the world. Thank you.
Thank you very much, Benny, the leader of our major space project, SKA, for giving us that progress as to what's happening as far as the SKA is concerned, which seems to be having good collaboration with a number of countries in Africa and a huge HCD component. Let's now move on to Terry Newby, who will tell us about what his institution is doing. Thank you very much.
Sorry, before he does that, I would like to remind you, if you've got questions, our assistants will be moving up and down the aisles. Just raise your hand and write your question on the piece of paper. Thank you.
Good afternoon. Being the only agriculturalist on the panel, I'm going to give you a bit of an agricultural perspective. I think the first point that I need to make is that farming in South Africa is not easy. We have a very unreliable and variable rainfall. Most of the time our average rainfall is below, or our rainfall is below average, more than it is above average. And we have prolonged and severe droughts, normally followed by floods and fires. So I think the statement that it's not easy to farm in South Africa indicates that we need all the technology we can get, and Earth observation being one of these is required. I think the second point that I need to make is that there's a large investment made in agriculture. If we look at the GDP in most African countries, it's about 30 or 40% of the GDP that comes from agriculture. However, in South Africa, only 3% comes from agriculture, and if we add the agro-industries, it goes up to 12%. We have about 42,000 commercial farms, but in addition to that, we have about 650,000 what we call emerging or individual farmers that are becoming commercial farmers. The government is investing about 20 billion in capital investment in redistribution of agricultural land from the previously sort of white-owned lands to a more fair dispensation. I think there is also a large hunger in Africa. Even in South Africa, the latest figures show that at least 25% of our black and colored children have expressed hunger at some stage during the year 2010. World food production, they tell us, needs to be increased by 70% by 2050. That requires about a 30 billion euro investment a year, largely in emerging economy countries. Now, to protect all these investments, I suggest that the use of technologies like Earth observation technologies is really required. Now, if we look at agriculture and we see how Earth observation is used, there's basically 3 areas. It's used for mapping and monitoring of our resources, looking at soil, yields, rangeland condition, and the likes. It also can be used for what we call parameter retrieval. That's things like vegetation index, leaf area index, water satisfaction indexes, where we can actually see what our resources are doing. And then finally, it's used in decision support. We've heard of things like precision agriculture, various inputs to models, and used then with collateral information like socioeconomic data, it is very good for policy formulation and decision making. Looking at what we specifically do in the Agricultural Research Council as far as this goes, we have a fairly unique crop monitoring system where we produce the agricultural statistics or the crop statistics on a monthly basis. The system really copes for both commercial large-scale farms and small fields. At a recent workshop in Nairobi, there was a lot of interest in how we've developed the system and how it can actually be used in many of the African countries. The essential need for crop statistics results really from the idea of food security, knowing how much food we have. It helps to stabilize costs so that food becomes affordable, and it results in a fair sort of economic trading, especially in things like the futures market, where people know exactly what they are working with. The other area that we do a lot of work on is range and crop condition monitoring, including things like monitoring droughts. And here we get a lot of value from the GeoNetcast system. Conrad has mentioned Geo. As part of that, there is this GeoNetcast system, which he also mentioned, and there are receiving stations in most African countries now that receives this data that can be used for this monitoring. The AMIST project has also been mentioned before, and we're quite involved in that, in providing the drought service. The agricultural service that Conrad mentions is in fact done from Botswana and not from South Africa. Moving on then to land cover is another area that receives quite a bit of attention, very useful for things like land use planning, looking at climate change and the effect of climate change on land use, carbon monitoring, and many of our coarse resolution satellite images gives us very good data for looking at land cover change over time. The other aspect that's very current issue in many countries is degradation of our resources. And we've put quite a bit of effort into looking at invader alien vegetation, specifically as it affects productivity of our agricultural land, specifically our rangelands, and also reduces the ecological services. Things like our water production are severely affected by alien invader plants. And it's a bit of a creeping surprise because you look at it today and you'll say there's a few around. Tomorrow they will have doubled, and the next day the whole area is full of invaders. So one needs to really pay attention to this. As an example, Swaziland has in fact declared a national disaster around the Chromalina odorata plant, which has really invaded all their rangelands and severely reduced the productivity there. So what is important for things like earth observation in agricultural development? I think one can say that it's a pretty essential piece of technology for providing information for national and local policy making and planning. We want to know where, what is, and where should it be. Those type of questions all get answered with earth observation data. It's very useful for monitoring trends, looking at climate change and degradation. It's essential for early warning systems, very important for food security, price stability and sustainability, and also for disaster management, looking at things like floods and droughts, which are a major issue in agriculture in Africa generally. If I move on to the question of international collaboration, we're certainly very active in the GEO community of practice around agricultural monitoring. Conrad has mentioned GEO. We in fact have recently registered a GCAM site, Joint Experiment for Crop and Agricultural Monitoring. It's where all the nations that are involved in the community of practice on agricultural monitoring can share their data around these experimental sites, test out various technologies of monitoring crops and sharing the experiences. And then we're also involved in the Access SatRep project, which is looking at the agricultural applications of things like seasonal forecasts generated from the global circulation models. I think in concluding then, just looking at the challenges and opportunities that we have in Earth observation in agriculture, I think there's a big need to increase the appreciation of Earth observation technologies and the data amongst specifically decision makers at your municipal, provincial, and even your national level. I think there's a big resistance to change, to using new technologies. It's often perceived as complicated and costly technology, and those things really need to be addressed. I think one of the issues is access to data. The volumes of data that you get in Earth observation, the bandwidth that's required to move this data around the country, especially down to municipal level where it can be used at sort of local decision-making level, needs to be addressed. The GeoNetcast system has certainly put a big step forward in this, in getting the information into most African countries now, but we really need it down to municipal level in some way. The human resource capacity, I think, is important. We need to really look at
I hope our panelists could now conclude, please.
Okay, thank you. I think the ground reference data that we need to validate and calibrate this also needs to be looked at in some way. And I think, yeah, let's leave it at that.
Thank you very much, Terry. Thank you, Terry, from the Agricultural Research Council. And Terry is actually displaying a very, very essential space application around the agricultural sector, which talks to food security, which is hitting all of us as the basic needs. We'll now hand over to Professor Herman Steyn. His presentation is already up there. Professor, over to you from the University of Stellenbosch.
Thank you, Nofeneko. I just want to give a couple of slides, quick history overview of what we already achieved building space hardware in South Africa. It started off in 1991 as a student project, master's and PhD student project at the University of Stellenbosch, when we decided to build a small microsatellite. And at that stage, when we began the project, it was really one of the most advanced microsatellites, fully 3-axis stabilized push broom sensor for imaging. Unfortunately, the launch was delayed, and we didn't complain because it was for free in any case. But during the program, we managed to train more than 100 students who worked on the project, various parts of the project. And eventually the satellite was launched and was operational for roughly 2 years in orbit. And we obtained many images that was taken by the SunSat camera system. The same camera system was also exported to the South Koreans on CubeSat 3, and many other components that was developed during the SunSat program was exported. Coming to the next project, it was for an international customer with a much better resolution than the SunSat project. There's a photo in the top right corner of the imager of that system, and one of the first images that we downloaded from that satellite is visible. And this satellite is still operational now, more than 4.5 years in orbit. Then we started in with the Sumbandila project, 83 kilogram project satellite that was built for the Department of Science and Technology. So it was the first real involvement of government in our activities, and we built this satellite, a small satellite with a 6.25 meter ground sampling distance imager, 6-color band, and various other experiments also on the satellite, the propulsion system to do drag compensation because the satellite was at a very low altitude, 500 kilometers. It was really a technology demonstrator. It was low cost, less than $2 million was the cost of the satellite, excluding the launch and commissioning. And we managed to get in 2 years' time more than 1,200 high-resolution images from the satellite. At the moment, the satellite is experiencing some problems. We hope to recover the satellite, so it's not totally failed yet. All the satellites that was on this launch, by the way, has failed already. So Sumbandila was actually the longest of these satellites operational. The satellite was built by a spin-off company called Sunspace from University of Stellenbosch. And we also did, in parallel with the project, some human capital development. We trained more than 20 master students, 2 PhD students, and a couple of interns from previous disadvantaged community were also trained at Sunspace in satellite engineering, and some of them are still working in this field. The launch was in 17 September from Baikonur. This is one of the imaging products from Sumbandila. You can see where we are, little white dot there in the top center of the image, at the convention center, and the imager is on the bottom left corner. At university, we still involved with CubeSat projects with our students at CPUT, Cape Town Peninsula University of Technology, on a SATI program, French South Africa program. They train roughly 30 master students and currently working on 2 CubeSats, ZACube 1 and 2. At Stellenbosch University, we're collaborating with them. We're doing the ADCS attitude control for their satellites. And at Stellenbosch itself, we're also involved with the Surrey Space Centre in the UK on the FP7 project to demonstrate solar sailing, first time solar sailing on a CubeSat mission. Okay, that was a little bit about the history. About the questions, I think I've answered the first question of what we're doing. The second question is our international collaboration. Yes, we do collaborate internationally. Our successes already attracted many international universities and institutions to us to collaborate. We're involved in many exchange programs. Some of our students go overseas for periods of time and they send students to us. We have also trained engineers for international companies in space or satellite engineering specifically in the past. Also at postgraduate level, we had students or people with PhDs participating in our activities. The challenges for us that needs to be addressed, I think one of the big challenges in South Africa is to make the average South African citizen aware of the advantages of space and space programs, and also to convince them that this is not all pie in the sky type work we're doing. It's work that can help improving the quality of life for everyone. We also need to attract excellent students from all our communities to study science and engineering at universities, and there's no better motivator than showing some work in space. That has been demonstrated all over the world as a big method of attracting young people to science and technology. We also have to establish partnerships with countries and companies with advanced space capability. And one of the things that I need to stress is that this type of partnerships must always be at mutual benefit. It must be at mutual benefit for both sides and not just go one way. Thank you.
Thank you very much, Professor Steyn, for giving us that evolution of the South Africa's capability in terms of manufacturing of microsatellites to now the CubeSats, as well as sharing with us the huge HCD component and that we need to actually bolster, and that needs to be coming from all various environments and angles, such that we can be able to push the space agenda in Africa. The challenge is very good, that we all need to convince the public out there and the politicians that space is not only about going to the moon, but also help us with the agricultural issues, as our previous panelist has mentioned. We now hand over to Leanne McKinnell to give us her views about the responses. Leanne, over to you.
Thank you very much. Good afternoon. I will be answering the questions from the point of view of the Space Science Directorate of SANSA, which is the facility that I manage. As SANSA Space Science undertakes the following, I will also be phrasing my answers with respect to our African collaborations, as the questions called for that. SANSA Space Science undertakes the following: fundamental basic space physics research. Several projects in this line have African partners, in particular at the moment with Kenya, Nigeria and Zambia. And these partnerships include bilateral research visits with hosts on both sides. Space weather activities. SANSA Space Science operates a space weather center, and we do space weather activities right from research to forecasting and prediction. And we currently have the mandate to be the regional warning center for space weather in Africa, which means that we have the responsibility of coordinating African space weather products and delivering information. We operate and manage geophysical instrumentation, such as magnetometers and GPS receivers in South Africa and Namibia, and in partnership with Nigeria. Geomagnetic field surveys are also conducted throughout Southern Africa in collaboration with African partners. A large part of what we do also is in line with human capacity development and science advancement. And the student training programs that we have include African students undertaking MSc and PhD degrees on research projects where the students are based at our facility but are registered at universities throughout the country. We contribute to the National Astrophysics and Space Science program, which takes in African students, and we provide opportunities for students from throughout Africa to participate in our programs. For example, we have a very vibrant Antarctic program where we operate instrumentation down at the South African base, and we have a number of projects, particularly in line with space weather at the polar regions, that take place down there. For this program, we send people down to the base to work on our instrumentation for a 3-month period over the summertime. And for the last 3 years, we have included students, and at least one of those students in each takeover team is from another African country. This year, in particular, we are also taking students from CPUT, from the CubeSat program, because the payload on board ZA Cube 1 is a payload that was developed in collaboration with SANSA Space Science. Okay, until recently, the African continent was largely unexplored in terms of geophysical infrastructure that would allow data to be collected so that knowledge of the space environment pertaining to the continent could be obtained. South Africa has been able to work together with our African partners to leverage contacts in the international community that have led to the installation of equipment for monitoring the space environment and also to capacity building within the space science field. These partnerships have led to an increased awareness of the space environment, an enhanced knowledge of space weather effects over Africa, which, by the way, is an incredibly interesting region scientifically, and a problematic region operationally for the space program due to the magnetic dip equator that passes through the middle of Africa, and an increase in research capacity in this field. The success of the African program lies in the hands of African nationals, and capacity building in Africa should take into account the need for skilled people to manage the ground-based infrastructure for the program and with the ability to turn the data into information. We collect an amazing amount of data, but we really need skilled people to turn that data into information so that we can use it. To address the question of international collaboration, in terms, as I've mentioned in my previous sentence, in terms of scientific research into space activities, Africa is a fascinating region, with more science questions than answers at the moment. Our international partners are fascinated and eager to deploy instrumentation in the African region, and we should provide them for opportunities to do so on condition that African scientists are equal project partners in the research projects. In this way, African scientists will get the opportunity to grow and develop as scientists by using their geographical advantage, and the international partners will get reliable data from infrastructure that is maintained by colleagues that have a stake in the project. In Africa, geographic advantage is very important as it leverages us, the global stage, particularly in space science. However, we have to be prepared to take advantage, and that means getting young people interested in science and identifying the science questions that are important to Africa. One of the science questions that we are addressing at the moment is the societal impacts of adverse space weather. There are, of course, challenges with this, and we're working together with our African partners to address that. These challenges, and I'll just mention a few of them here, include the lack of high-speed internet access, which makes data transfer and communications difficult, the lack of critical mass in key areas, which some of my colleagues here have mentioned for their areas as well, creating an awareness of the importance of space in everyday lives, which is something we're all addressing at the moment. How can we address these? Well, the one that we're working on, all of us are working on, is addressing it through the capacity building in key areas, which means using science advancement, using space as a driver to excite an interest in science, and being proactive in talking about what we do and the benefits of what we do. There are many opportunities that exist for doing science in Africa, and these opportunities lie in existing bilateral agreements between African countries, such as the Kenyan-South African bilateral and other bilaterals that are coming up at the moment, emerging space programs in Africa, the interest that international partners have in working with African partners, and in particular in our geographic advantage. And the geographical advantage is not only South Africa being at the tip of Africa, but it is also our African partners and their countries being close to the magnetic dip equator, being in an area that has a paucity of historic data. We can leverage these opportunities through being open to international partners, convincing our colleagues to take advantage of the bilateral programs, and to include students on their project proposals. One of the things that we've done recently, just as a digression, is to invite several African students, African scientists, to send their students to us at the same time, to spend time with us. This means that not only do they work in our programs, but they meet each other and make contacts with each other as for future working together partnerships. We should develop scientific project proposals that utilize our geographic advantage and assist us in becoming experts in this field, in this area. When I talk about us here, I'm not only talking about South Africa, I'm talking about Africa as a whole. Thank you.
Thank you very much. Thank you very much, Leanne McKinnell from SANSA, Space Science Program, for sharing with us those various important programs that you are pursuing there. Collaboration with Africa, which actually is very key for awareness and also bringing young Africans to the space program. We'll now call upon Raul Hodges, who's also from SANSA, to share with us what they are doing in SANSA space operations. Raul, over to you.
Thank you, Nofuneku. I head up the part of SANSA space operations, which is situated in Hartbeespoort, probably one of the most sought after locations in the space business in Africa as well as in the world. We have an amazing location at Hartbeespoort with a 2-degree horizon mask and as much bandwidth as possible at the moment. Furthermore, we do many fascinating things. First of all, we do transfer orbit supports, where we place communication and satellites into orbits for international companies on a daily basis. We also do life cycle supports, where we monitor satellites for international companies, as well as our own satellite, Sumbandila on a daily basis, to see if there are any issues or problems with the satellite, and we try and fix them at the same time. Due to our location, we're also very privileged to be able to do emergency supports. typically we have all the frequency bands available to us from L band to as high as Ka band at the moment. And this gives us a unique opportunity if a satellite is in trouble for any international client or African client to be able to help as soon as possible or as fast as possible and maintain the satellite in its current position until we can further look at issues with the satellite and help repair it. Due to the vast amount of satellites looking to the northern hemisphere, we are also able to do the carrier monitoring from the southern side of the satellite, which we call the back end, and that gives us an opportunity to monitor the carriers, which then enables the satellite owners to use their satellites more efficiently on a daily basis. And as my colleagues or co-presenters said, talked about remote sensing and the uses of the data, we are also one of the only stations in South Africa which downloads the data on a daily basis and the remote on the TM data from satellites. We archive this data, we also process this data. By that we take this data and we supply it to all government departments free of charge in South Africa. Now SANSA endeavors to give as much data as possible to all government departments in any format. The problem is that we are not able, one of the challenges is that we're not able to fulfill the whole spectrum of Earth observation data as needed by any country, as well as needed by SADC and Africa. We only have so much money at the end of the day and only so much resources, which leads us to the next challenge, a South African-owned satellite, which can complement the data we purchase internationally for our own uses. And that gives you a full cycle at the end of the day. Another challenge, the more satellites you have as a country, the more data you can supply, and the more you can create or help for the social benefit of the country. So it is key that we start exploring the build of satellites and fulfill the whole chain, from the building of the satellites to the monitoring of the satellite to the use of the satellite data in South Africa. We also host infrastructure for international clients at Hartbeespoort at this specialized environment linked to space activities in the world. One of the other challenges we mastered in the past 3 years due to the very own building of our own satellite, Sumbandila Sat, was to be able to mission control our own satellite. In the past we were not able to mission control a satellite due to the very fact that we did not have a satellite, and you have to have the opportunity to have a satellite to be able to do mission control and acquire those skills. It's been a great learning curve for us in this field to be able to work with a satellite builder and the universities to develop the software, develop the skills and the people to be able to operate our own satellite day by day. What even improved the challenge is, as we heard that the satellite is in safe mode at the moment, is to be able to get the satellite out of that safe mode twice and functioning twice again. That gives you the experience of learning. Nowhere else will somebody else allow you to do that on a commercial satellite. And those challenges is what makes special training in our environment. To touch on that, we also work closely with the navigation community throughout South Africa, SADC, and Africa. Presently, we're busy looking at the rollout of EGNOS into South Africa. In collaboration with the SADC region, we're looking further to be able to roll out EGNOS into the SADC region, and then further into Africa at a later stage. And this is all to improve flight safety and navigation in Africa for Africans. When we talk about HCD, I've mentioned many facets of what we do in the space business within space operations. And if you have all those facets of business within space operations, you need skills. What then puts us in an advantage is to be able to train many interns, artisans, technicians in the very field of tracking satellites, putting satellites in orbit, fixing antennas, which is not exactly your master's and PhD skills, but it is a very effective skill that we need in South Africa as well when we start looking at the broader spectrum of repairing stuff and maintaining equipment of such high standard. Furthermore, we are also seen as the international gateway into Africa, and a role we'd like to continue doing in partnership with Africa. We've been in the satellite business for close to 50 years, or surpassed 50 years, and we have huge respect for the international community as well as they have for us. And we would like to share that and open the doors to the African community regarding space. If I go to the last question, what are the challenges? I strongly believe that the challenges for us is coordination and cohesiveness into Africa and SADC. I also believe the other challenge is that the full chain of satellite engineering, from building, operation, and planning of our own satellite must come to fruition. I thank you.
Thank you very much, Roel, from Satellite Operations Center. Busy with satellite tracking, telemetry, and command there. And what is coming out very strongly from all the panelists is the issue of skills development, skills challenges, and coordination. I'll now call upon our chairperson to come back and join me here for a number of other questions that are coming from the floor. Would like to give you a good chance to give to ask questions. What you, Sandile?
Okay, thanks so much. Okay, I'll ask a set of two questions, two directed to Benny, and then two directed to Terry. The first one, well done for your efforts with SKA. SKA supports astronomy. What are the plans to fund the space technology students? What is the educational roadmap for astronautics and space technology? How will you proliferate it throughout South African universities? That's the first question. And then the second question.
That again?
Okay. Well done. It's essential to you and other astronomers. The first question is, what plans are there to fund space technology? And what's your roadmap in terms of for astronautics and space technology, and how you will ensure that the other universities within South Africa have programs in that area? Okay, that's from one person. And the second one, it's about, the issues related to the management of our astronomy facilities that are not being managed appropriately once completed. An example given is the SALT project that has not, according to the participant, not functioned optimally. Will this also affect the bid for SKA?
Thank you. I have a bit of a problem answering the first question because we aren't really looking at space technology per se. The kind of technologies we're looking at are mainly ICT technologies which are used in radio astronomy. So our bursary program is open to students from all universities in the country. What has happened though is that most of the bursaries have gone to universities which are focusing on astronomy or the related technology areas. We're also now developing quite a big undergraduate program in physics and engineering. We have about 100 students in that program, and we're training technicians and artisans as well, not only from South Africa but from the other countries. But astronautics and space technology is not really something that we are looking at. About the management of astronomy facilities, there is now a process looking at the consolidation of the two radio astronomy facilities. One is a Hartbeespoort Radio Astronomy Observatory near Pretoria, and the other one is the SKA South Africa activity. So that's the Meerkat and Paper and Seabass and the observatory and so on. The idea is to build up a national radio astronomy facility in South Africa, and the National Research Foundation has been working with the ministry on developing a model for that. So we're hoping that'll happen fairly soon. Optical astronomy is managed separately through the South African Astronomical Observatory. I think the SALT telescope is now up and running and has been commissioned and is producing very good science. All of these cutting-edge technology areas are open to problems. What we're doing with the Meerkat is running a very tight system engineering process so that we know exactly what we have to build, how we have to build it, and how we have to build the interfaces. We recently had a preliminary design review of the Meerkat by an international panel, and one of the things they singled out was the fact that we'd been able to run a very formal system engineering process, which at the same time was able to take account of the fact that we're developing cutting-edge technologies. So our team has been able to produce the CAT-7 prototype, for instance, on time, and to integrate the equipment in Cape Town, but put it out in the Karoo, and it works when you switch it on. So we're hoping that that sort of approach will be able to ensure that what we build will operate according to spec.
Thank you very much, Benny, for the response. I hope the participant will be happy, content with the response. I now have two questions directed to Terry. Two questions for you, unfortunately. The first one, what is the research field like in South Africa, and specifically the SADC, with regards to using Earth observation for water resource management in support of agricultural activities? The other question from the same person, what is the collaboration with the Water Research Commission and the Department of Water Affairs? Let me ask you another question, Terry. They're coming in numbers for you. How can the mentioned emerging commercial farmers in South Africa profit from the precision farming technologies that you alluded to earlier on? Thank you, Terry. Over to you.
Thank you. This is a bit like an exam. Okay. The research fields around water resources, our specific institution is not really into the water resource as such. The Water Research Commission is the main funding body around water research, and a lot of it is being done in that field. There are a number of Water Research Commission projects which uses Earth observation to look at our water resources. The Department of Water Affairs itself is using it fairly widely for monitoring the legislation around the Water Act. There is a lot of research going on looking at evapotranspiration modeling and such things to try and get a handle on how much water crops are using. So I think plenty of research is happening in the water and hydrological field, but not specifically within the Agricultural Research Council as such. Collaboration with the Water Research Commission. The Water Research Commission is basically a funding agency. They put out calls for proposals, and we certainly respond to them. A lot of our research around water is not necessarily Earth observation based, but we are looking at irrigation, water harvesting, and areas like that. Looking at the question around the emerging farmers and precision agriculture, at this stage we're not doing too much around that area. There is a lot of potential. Resources limit us to getting involved there at this stage. However, in Africa there are projects looking at this. The CIGIAR organization, I think, has a project in West Africa where they're actually using high-resolution or very high-resolution images, looking at communities that actually examine these images and then discuss amongst themselves how to plan their fields and look at the condition of the crops on the fields from these high-resolution images. So certainly there is potential there. It is being used, and certainly it is something that we need to move into.
Thank you very much, Terry, for taking that exam so well. We have another set of questions. These two questions can be taken by any panel member. The questions are as follows. Are there any plans to educate the public about the advantage of our space program? Since it will be difficult for the man on the street to justify spending millions of rands in space when South Africa has seemingly more important problems such as poverty and high unemployment. So we need to convince the man on the street, why are we using millions for space and not poverty and high unemployment? I think any panel member can take that. Benny, thank you.
Chair, thank you. I'm not going to talk about specific plans for outreach. I just wanted to talk about some of the reasons why we do the program. We have immediate problems, short-term problems of housing and food and health and education. At the same time, we can't limit ourselves to only solving our immediate problems of poverty and inequality. We have to have a longer-term vision, both for South Africa and Africa. There have been many studies now which have said that Africa is the next great economic growth story. Africa is the next great business destination. We've had tremendous interest from multinational corporations because they see Africa as such an important growth area. So we've signed mutual benefit agreements with IBM and Intel, for instance, and we're working very closely with Nokia Siemens Networks, because they see a benefit in working with us because our teams are good, but they also see the potential in Africa. What do you need to be able to realize that potential? You need primarily skills and infrastructure, and you need to recognize the importance of those things. So the outreach that we're doing from the SKA project is around astronomy in general, but particularly about the project that we're doing. And I think that the message that we're putting across to people is that these are inherently very exciting subjects. Secondly, that we're training up a cadre of young people who have really cutting-edge technology and science skills as good as anybody anywhere in the world. And thirdly, that we're transforming the way both Africa sees itself and the way the world sees us as a place where you can do high-tech investment, where you can do science that's at a cutting edge. We're not just the Africa of the basket case that you see in the media.
Thank you very much, Benny, for that response. Leanne would like to also respond to this question of why are we using millions, and I think the space applications bear testimony to this. Leanne?
I just want to give a perspective from SANSA on the science advancement side. SANSA is committed to the science advancement, to bringing the message out there of why we're doing space activities, the success of the space activities, and how they're going to benefit the people. We already have a very vibrant science advancement program in place. We will be visiting every province and taking part in exhibitions. All the SANSA directorates are committed to that. We will be putting on public lectures. We will be telling you what we're doing, and we'll be telling you the benefit of what we're doing the whole time we're doing it. We're absolutely committed to that.
Thank you, Leanne. I've got other questions. This one is directed to Herman. I think it's on the space industry, which is also the domain of the DTI. What are the specific contributions the panelists would like to see from the industry, especially members of the AISI, Aerospace Industry Support Initiative, to aid the South African and African space activities? Herman, you think you take that question?
Yeah, I think it's a simple answer. We need funding. The space industry in South Africa is extremely small. It's minute. And if we really are serious about going ahead and establish a space industry in South Africa, it will require some funding. And one can also always import technology from elsewhere, but it will cost you more on the long run, and at the end you will not learn. You will not inspire your population and your young children to stay in the country and become part of an exciting story and be a proud South African. That's how I see it.
Thank you, Herman. I think we have heard the simple solution is funding. I hope my bosses were here. Any panel member? This other question. With South Africa's tremendous interest in space and our position as a mining world leader, what do you think about getting involved in mining space resources? Any panel member? With South Africa's tremendous interest in space and our position as a mining world leader, that means the natural resources, what do you think about getting involved in mining space resources?
I think we still have enough resources here on Earth to mine. And it will be extremely expensive to go and mine deep space, and we leave that to the rich countries of the world.
That's the view from our University of Stellenbosch panelist. Now we've got another question, 2 questions for RAL, space operations. Please comment on the commercial usage of space communication like direct TV and telephony. Another question, is Sumbandila Sat data available for African researchers?
Thank you. Let me answer the second question first. Yes, you can go to our catalog and all the data is available to any researcher, and anybody can request the data. That's on the catalog, it's processed, and it's ready for delivery. If we go to this the first question, which is regarding commercial viability of satellites over South Africa for TV and telephony and so forth. Presently, South Africa hires transponder space from satellite operators which have satellites in our arc, or which have satellites that have a footprint over South Africa. So transponder space is available. Presently, there's a huge shortage of transponder space over the footprint of Africa, which is presently also being looked at, where people with the opportunity and the funding will soon have satellites in those frequency bands and a footprint over South Africa. The question remains, once again, funding. Do we as a government invest in commercial satellites or in communication satellites for commercial purposes? Until we have not built big Earth observation satellites, we cannot take that step to build commercial satellites for communications. So I believe that's probably in the 10-year span from now, where communication satellites could be built in South Africa and have South African communication satellites serving our own purposes.
Thank you very much, Ralph, for responding to those questions on direct TV space telecommunications. I've got a question now for Conrad. Conrad, they're asking, aside from those activities that have been discussed, what other space activities, if any, are underway in South Africa? So there's somebody who's now looking at the future. What else? Or is it all that we have discussed now?
I'm sure I didn't mention all our space activities. I specifically addressed Earth observation and using space-based Earth observation. I'm not 100% sure what the question alludes to. Surely there's many activities. I mean, if I had half an hour to show you beautiful slides and all the initiatives, I would gladly do so. There's a lot of activities. I mean, there's involvement in so many Earth observation projects. You know, for example, the one we do with the Carnegie Institute of Science, it's actually an airborne sensor. It's a laser scanner that produces a three-dimensional impression of vegetation of the Earth's surface in combination with a hyperspectral sensor, which has about 200 spectral bands. And this was flown across a transect in Kruger National Park, where we look at the impact of humans, elephants, and fire on vegetation structure. And some of the very interesting results we found is that very big trees, or big trees in Kruger National Park and Sabi Sand are being lost at an alarming rate. And then just outside the fences in the communal area where 90% of the households rely on fuel wood for their energy, there the biomass is also reducing radically as a result of this harvesting, fuel wood harvesting. And we now have ways to measure that from the air. There are satellites being developed that can do that from space. And when you look at energy security, biomass, and carbon stock monitoring, certainly to do it from space and to do it in Africa is what we're all about.
Thank you very much, Conrad, for your response. I have two questions. Briefly, we're running out of time, and I can see people are running away. We're standing between them and probably lunch. One question for you, Benny. What will happen with the preparatory investment if South Africa does not win the SKA bid? What will happen to the preparations and the investment that we've put into it?
The Minister for Science and Technology has stated quite clearly that we'll continue to build and complete the Meerkat to be one of the best telescopes in the world. The SKA timescales are long, so the SKA will be completed well into the 2020s, 2024, 25. Until that time, Meerkat will be one of the world's premium telescopes. As I mentioned earlier, it's attracted huge interest already from astronomers, and we would hope to do really world-class science with a Meerkat for a long period of time. The expected lifetime would be 50 years, and even when the SK is operating, it'll be a premium telescope. Besides that, we are hoping to be able to expand the paper telescope. So in recent discussions we've had in the US, we've been talking about doubling the size of the paper telescope, and we're looking at attracting other telescopes. The African VLBI network would operate independently of whether the SKA comes to Africa or not. And that will also be a major scientific instrument which will enable us to work with the global network of telescopes and will enable African scientists and international scientists to do remarkable astronomy. So we would want to continue with the science. As far as the technology is concerned, the work that we've been doing on the Meerkat, both in our own office, in the universities and in the industries that we've worked with, many of which are represented here in the exhibitions, has enabled us to develop both the skills and innovative technology, which means that our industries and individuals will be able to play a leading role in SKA technology development and construction wherever it takes place in the world. So we don't believe that things will suddenly come to a halt if we don't win in March or April. We believe that we've got a very good chance of building the SK in Africa. So I wouldn't like for a moment to think that it's not going to happen. But it's a bit like predicting where the Olympics will take place next. So I do believe that our human capital program, our technology development, our industry development, and the use of Meerkat and the other telescopes for science will continue.
Thank you, Benny, to hear that it will not be all gloom and doom come March 2011. We have a medium to long-term plan as far as space science and advanced manufacturing technologies that will be coming out of the SK project. One last question, it's not last, one of the questions. One of the key challenges in the use of Earth observation data for applications is access to this data. What are the various institutional policies with regard to data access and sharing? Any member can take that. Policies regarding access to data and sharing data. Roel, you take that?
Yes.
All right.
Prior to April this year, prior to being part of the South African National Space Agency, the Satellite Application Center was required to buy data in from international companies and then distribute that data at a cost. Our main focus at the moment in SANSA is to acquire as much as possible data sponsored by government and distributed for the very purpose of this research. And we're trying at the moment to see how many sensors available we can get and distribute that data at a very, I don't want to say free, but a very marginal cost to all researchers and universities to develop applications for the good of the country. We believe we can only supply the data. We don't have all the skills to develop the applications at the end of the day. We have specialists which can discuss that. But the applications is key at the end of the day to supply an answer. Raw data or processed data is worth nothing if you cannot derive an answer from it. And in the light of that, we've changed our policy to be able to distribute as much of this data as possible at a marginal cost.
Thank you. Conrad, you would like to add?
Yes. If you look at it this way, high resolution data, let's say under 5 meter per pixel, that data is typically commercial, expensive, but becoming more and more affordable. They are provided by commercial companies. That is why, for example, Sumbandila Sat plays in that space. Because now a normal citizen can access data from our own satellite for free. And, you know, I had that experience as a researcher. I went online, I went to the catalog, and I ordered images from Southern Kruger National Park, and I got 4 images in 1 month from Sumbandila Sat. Those images would have cost me 40,000 Rand each if I bought it commercially. Now that's the high resolution, commercial grade stuff. Now if you look at the Earth science satellites, that are satellites that look at the atmosphere, the oceans, look at the whole Earth system, and there are fleets of them. All that data is for free. All that data is for free, it's accessible online. In addition to that, that's the NASA, ESA satellites. In addition to that, under the GMES program, the Global Monitoring of Environment and Security, there you have the Sentinel series, and they are being launched very soon. I almost think Sentinel-1 is very close to launch. All of that data, it's been decided by European Union, it's going to be free. So you have a radar satellite, high resolution, that's going to be completely free and covering the whole globe every 5 days, very high resolution. And Sentinel-2, which is a Landsat-like satellite, let's say 20 meter resolution. All of that data is going to be free. So, and I also have to take my hat off to our Department of Science and Technology, who leads the data democracy task inside GEO. And a lot of this negotiation that goes on to give people access to this data, our own government has had a very strong hand in that.
Thank you, Conrad, that the data for that response. The data will be available. In the interest of time, let me just make a comment, and then I'll hand over to my chairperson, who will answer his last questions and close the session. In the spirit of building capacity for Africa and in Africa, we have recently, this week on Tuesday, launched Women in Aerospace Africa. This is an organization for both men and women to actually mobilize ourselves, to actually increase the visibility of women in the aerospace sector. This organization will serve as a platform for networking and benefiting from the programs and special benefits of this organization. We all urge the Africans to join this organization, and especially young Africans, South Africans and Africans, and women to stand next to each other such that we can build the space program and the capabilities that are required for this huge task ahead of us. I'll now hand over to my chairperson to answer, have a fair share of the questions and close the session. Over to you, Sandy.
Okay, sorry. Even though I wasn't a member of the panel, there were a few questions that were addressed to me. I'll try and summarize this. Essentially, 2 of them relate to what exactly is our strategy as a country in terms of space. Are we intending to build a space shuttle, sounding rockets, and those kind of things? And where do we see ourselves going in the next 20 years? Our aim is not so much to build a space shuttle or to go to Mars, but is to use space science and technology to benefit the man in the street. That's our primary goal. And obviously, in the process of doing that, we'll probably need certain instruments and infrastructure to do that. And satellites are one way of doing it. And so we do intend to build our own satellites. We've done it already. We want to continue doing that. That will also benefit other areas in our country, our technology, our industry, skills as well. And so that's our aim, primarily, in terms of our goal. And then there's another one which says, we've received negative publicity in terms of Sumbandila satellite, and some of you might have read it. How do we intend to, convince our government that we need to be funded? Yes, it is a challenge. The country has many pressing needs, and we're fully aware of that. And I'm delighted that amongst ourselves, our parliamentarians are here, and they've been around to hear what we can do. Conrad mentioned, for instance, the cost that it would have cost him just to get 3 images. Those are the kind of things that we do. We've used the satellite very extensively. It's collected images that we've used to monitor what's happening in the Kruger. It's helped, for instance, in the disaster that happened in Namibia recently, floods. They were monitored through that satellite. In Japan, we used it as well during the earthquake. Those are some of the things that we've done. And we believe that we could do more. It wasn't an operational satellite. It was a prototype. It was designed for us to learn something. We've learned something out of it, and we want to go on and build an operational satellite that can do the kind of things that we need to do as a country to be able to assist in agriculture, water management, and many other things, planning, housing, and so on and so forth. That's what we're intending to do. Thank you. And I would like to end by thanking you for coming through to this plenary, and we trust that you will enjoy the rest of the day, which is the last day of this Congress. Thank you very much.